right, so we are going to continue our journey in chapter 2, where we're really just talking about logic. Okay, so we spent a couple days with our conditional statements. Okay, now we're going to work on some different types of reasoning. Okay, so a conjecture. Have you ever heard that word before? Who said yes? Oh, nobody said yes. Braden said yes?
Yeah, sure.
Braden, do you know what conjecture means? No, do you have a guess? So it's an unproven statement based on observations. You observe something, you make a conjecture. I can smell lunch wafting through the. Is this yours, Corbin?
Yes, thank you.
Okay. Now, inductive reasoning is a form of reasoning that we base off of patterns. Okay. So in math, we like patterns. Okay. So we're going to work on if we follow this pattern, what will continue to happen. Now, we're also going to work on some deductive reasoning strategies. Inductive versus deductive. Inductive, we're using like patterns to help us. Whereas deductive, we're using facts, definitions, accepted properties, and the laws of logic. We're actually going to, there's a couple laws of logic that we're going to talk about today. They have some fun names to them. Okay. Where we use these based on facts and logic to get to the next, to get to our conclusion. Okay. All right, so under inductive reasoning here, okay, we've talked about it, what a conjecture is. We've talked about inductive reasoning. Okay, let's use it to follow a pattern. So I want you to write this down for me. I want you to write down the numbers 12, 17, 22, 27, 32. But I want to know, what are the next three terms? Braden, you have an idea? How'd you get those? They went 5 up every time. So you decided to go 5 up for your next 3 terms. Does his reasoning make sense?
Yes.
Do you agree that these are the next 3 terms? I agree with it.
It's a possibility.
I say his logic is pretty sound. All right. Write these numbers down. 1, 4, 9, 16, 25. Presley is excited because she thinks she has found the pattern. Presley, what is special about these numbers? They are all perfect squares. So what would the next 3 numbers be?
36, 49, 64.
Okay. So up here we had a pattern where we were adding the same number every time. Here we have a pattern where these are all sequential perfect squares. Okay. You could have a pattern where from number to number, you are multiplying by 2 every time. Okay. Or we have a very special sequence of the Fibonacci sequence. Who knows it? Harvey? Do you know what it starts out as?
Oh, this is an option sequence.
Is it 1, 1, 2?
It's one,
Yeah, 1, 1,
then 5,
then 8,
then 8,
then 32, then 21.
Yep. So on my husband's birthday a few years ago, I decorated a cake that looks like this. So the Fibonacci sequence, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5. You see it? So on what birthday did I make a cake for my husband? Try again.
34.
34. Okay, this is also yep, so this is the spiral. This is the golden ratio spiral. So like this square has sides 1, 1, 2, 3, 5, 8, and then we could keep going. Yeah,
I think
where
that's
it
what we
comes from.
said about.
Think so? Okay. I have a necklace that has that. I'll try to remember to wear it next week. Are you making fun of me?
No, I'm not making fun.
Dang. Are you sure? Are you sure, Ben?
No, I'm not.
It's okay. You can make fun of me. All right. Next page. Let's talk about some deductive reasoning. Okay. Deductive reasoning, remember, we're using facts, definitions, and properties. Okay. So we have 2 things. We have something called the law of detachment. We also have something called the law of syllogism. They're fun words to say. Okay. Let's first talk about the law of detachment. Okay. If the hypothesis of the conditional statement is true, then the conclusion is also true. Okay, so here's what we're looking at here. Let's say I gave you this statement. I want you to write it down. If a figure is a square, then it is a rectangle.
rectangles or squares and all squares and rectangles.
Rectangles are not always squares, but squares are always rectangles.
It's not a bi-conditional.
Okay, so I am giving you a conditional statement. I then will give you a separate statement altogether. A, B, C, D is a square. So I'm giving you a true conditional statement, and then I'm giving you something specific to the hypothesis. So do you notice that our hypothesis, if a figure is a square? Now I have a specific example. A, B, C, D is a square. Okay, well, what would our conclusion be? What, Brayden? If a figure is a square, then it is a rectangle. I'm telling you, ABCD is a square. So what do we know about ABCD? It's a rectangle. Okay, so what's happening here is you get a conditional statement. If you are given some information about a specific example that matches the hypothesis, then we can specifically jump to the conclusion. Okay, now, if I said ABCD is a rectangle, I could not use the law of detachment. But since we had the statement ABCD is a square, it matched the hypothesis, then we were good to go. Now, the law of syllogism, I kind of like to call this the transitive property of logic. Who can tell me what the transitive property is? Not everyone all at once. Then, if A equals B and B equals C, then A equals C. You see it? That's a transitive property. Okay, so the law of syllogism. If P implies, well, here. If P implies Q, and then we have if Q implies R. So notice how the conclusion of the first conditional statement matches the hypothesis of the second conditional statement. Then the law of syllogism says, okay, well, then that means P is going to imply R. See how that works? So under this notes part, if 2x plus 4 equals 8, then 2x equals 4. That is a conditional statement. If hypothesis, then conclusion. Second conditional statement, if 2x equals 4, then x equals 2. Okay, so I want you to notice that the conclusion of statement 1 matches the hypothesis of statement 2. So the law of syllogism says that we can conclude that if 2x plus 4 equals 8, then x equals 2. We can take the hypothesis from the first and it will get us to the conclusion of the second. While keeping your student journal open, maybe just like push it to the top of your table, I want you to open to page, get mine, page 4 of your packet. Okay, so what I want you to do, I want you to look at these two right here. These two, I want you to use the law of detachment. So the first one we talked about, the law of detachment. I'm going to give you 1 minute to come up with a conclusion based on the law of detachment, and then we'll talk about it together. Just these two right here, using the law of detachment. Yep, write the conclusion. If a student attends LVMS, then they are a monarch. Joe attends LVMS. Harvey, what can we conclude? Since this statement matches the hypothesis, we can specifically go to the conclusion about Joe. Nora, what do you think about the second example?
Rico does not bark at the
Okay, I like where your head's at. And I'm guessing she's not the only one who put that as an answer. However, we can't come to a conclusion. We have, if the animal is a dog, then it barks at the mailman. Rico is a cat. Well, it's not a dog, so I don't know what's going to happen. Okay. If it doesn't match the hypothesis, we can't come to a conclusion. Okay. Now, in our minds, we don't think the cat is going to bark at the mailman, but we have no evidence to support it.
She might yell at you.
We don't know. We don't know. All right. Now, these next two are the law of syllogism. Okay. So I want you to come up with a conclusion. If there is a conclusion, you are basically writing a new conditional statement from these two. Okay. So write down what you think works. Yes, and your conclusion is going to look like a conditional statement when you're using the law of syllogism. You can talk to each other about it.
Do we, are we posting both of them right now, or?
Yep, we're gonna go over both of them. Okay, what do you think about this first one? Do we have a match? Why do you say not really?
It's like soccer practice is canceled, they say that like twice.
They do say that twice, and is one a conclusion and one a hypothesis?
Yes.
Yes. So what we can do is we can say, okay, since the soccer practices match up, we can say, if it is raining today, you can go to the mall after school.
So the ones that match, you don't put in it.
Right. So like the conclusion and the hypothesis, basically we sandwich together, right? Now, what about this one? If a figure is a rectangle, then all the interior angles are 90 degrees. If a figure is a square, then all of the interior angles are 90 degrees. Is this in the order we need it to be?
No.
What matches? Okay, and that is the conclusion in both statements, right?
Yes.
In order to use the law of syllogism, we need the statements that match. One needs to be conclusion, one needs to be a hypothesis. So this is not matching up with what we need. Okay, we have to have that transitive property there. Okay. Okay, we have 10 minutes left. It's a Friday. Let's go ahead and you can start your homework, which is the student journal. So I believe it starts on page 42 and it continues to page 43. You're gonna do all the problems 1 through 12. Okay?
That's what I thought.
Well, if you get it done in the next 10 minutes, you won't have homework. Yep, I have some back on that black table.